Question 843. What is the slope of tangent line to the curve r is equal to 4 sine 2 theta at theta is equal to pi over 4? Okay, here we have a polar curve. R is equal to 4 sine 2 theta, right? Remember, x coordinate in terms of r and theta is always equal to r cosine theta, and y coordinate is r sine theta, right? So, since r is 4 sine 2 theta, we have a 4 sine 2 theta times cosine theta. And our y coordinate is r, which is 4 sine 2 theta times sine theta, right? Since the question is asking us to find the slope of tangent line, slope is always equal to dy over dx, right? And in terms of theta, that can be written as dy over d theta dx over d theta, right? So we're going to have to differentiate this x in terms of theta, y in terms of theta, right? So let's find dx over d theta first. So dx over d theta is equal to, here we're going to have to apply the product rule, right? Since this is 4 sine 2 theta times cosine theta, right? So leave 4 alone. Derivative of sine 2 theta, that's cosine 2 theta times chain rule 2. And we have cosine plus, leave sine 2 theta alone, and multiply by derivative of cosine, which is negative sine, right? So dx over d theta, when theta is pi over 4, we're going to substitute pi over 4 for each theta. Pi over 4 here, pi over 4. Then dx over d theta, when theta is equal to pi over 4, that is equal to 4 times, here cosine pi over 2, that's 0, right? So 0, 2 times cosine pi over 4, that's root 2 over 2, plus sine pi over 2, that's 1, negative sine pi over 4, that's negative root 2 over 2, right? So all of this thing is 0, and 4 times negative root 2 over 2, that's negative 2 root 2, right? Now let's find dy over d theta. So we're going to differentiate this expression right here with respect to theta. Again, we have a constant 4. Here we have a sine 2 theta, right? Derivative of sine 2 theta, that's a cosine 2 theta times 2. And we have a sine plus, we have a sine 2 theta, and derivative of sine, that's cosine, right? Again, substitute pi over 4 theta, right? Pi over 4. Then let me write right over here, dy over d theta, when theta is pi over 4, is equal to this value right here, cosine pi over 2, that's 0 again. So all of this expression equal to 0, right? Here sine pi over 2, that's 1. So 4, 0 plus 1, cosine pi over 4, that's root 2 over 2. So that is equal to 4 times root 2 over 2, 2 root 2, right? So our slope when theta is equal to pi over 4 is equal to dy over d theta, that's 2 root 2. Dx over d theta, that's negative 2 root 2, right? So the slope is negative 1, right? Question 846. The figure above shows the graph of the polar curve r is equal to theta plus sine theta. write the equation of the tangent line to the curve at theta is equal to pi over 3. Okay, in order to find the equation of tangent line, we're going to have to find the slope first. And slope is dy over dx, right? But in polar curve, we have to write dy d theta, dx d theta, right? And remember, x is r cosine, y is equal to r times the sine theta, right? So our x is equal to r is a theta plus a sine theta, right? So theta plus a sine theta, r cosine. Dx d theta is then, by applying product rule, derivative of this with respect to theta, that's 1 plus cosine theta. And we have cosine theta plus, we have theta plus a sine theta times the derivative of cosine, which is negative sine, right? So at theta is equal to pi over 3, we have, I'm going to substitute pi over 3 here, right? Then that's going to be equal to dx over d theta is equal to 1 plus cosine pi over 3. That's 1 plus 1/2 times cosine pi over 3. That's 1/2 plus pi over 3 plus a sine pi over 3. That's root 3 over 2 times the negative sine pi over 3 negative root 3 over 2. Right? So if we simplify this, that's going to be equal to 3 over 2, 3 over 4, right? Plus, that's negative root 3 pi over 6 minus 3 over 4. So that's going to be equal to negative root 3 pi over 6. Now let's find the derivative of y with respect to theta. Here y is r sine, right? So theta plus the sine theta times the sine theta. Then dy over d theta is equal to, derivative of theta plus sine theta, that's 1 plus cosine theta. And we have a sine theta plus, leave r alone, theta plus the sine theta. Derivative of sine, that's cosine, right? Again, substitute pi over 3 for theta, right? Pi over 3 for theta. Then that's going to be dy over d theta is equal to, well, cosine pi over 3, that's 1/2, right? So 1 over 1/2 times sine pi over 3, root 3 over 2, plus pi over 3, plus root 3 over 2 times cosine pi over 3, which is 1/2, right? So that's going to be equal to 3 over 2, then root 3 over 4, plus pi over 6, plus root 3 over 4. That's going to be equal to pi over 6 plus 3 over 4 root 3, 1 over 4 root 3. If we add those two terms, that's going to be 4 over 4 root 3, right? Which is just root 3. So plus root 3, right? So our slope is equal to dy over d theta, that's pi over 6 plus root 3, over dx over d theta, that's negative root 3 pi over 6. So let's multiply by 6 and 6 here. That gives us pi plus 6 root 3 over negative root 3 pi. That's our slope, right? Now we're going to have to find the x and y coordinate when theta is equal to pi over 3. So x is theta plus the sine theta times cosine, right? So let's write right up here. X is, when theta is pi over 3, That's going to be pi over 3 plus sine pi over 3 times cosine pi over 3. So that is equal to pi over 3 plus root 3 over 2 times cosine pi over 3. That's 1/2. Right? So if we distribute this, that's going to be pi over 6 plus root 3 over 4. Right? What's y? Y is equal to, again, when theta is equal to pi over 3, that's pi over 3 plus sine pi over 3 times sine pi over 3. So that is equal to, we have a pi over 3 plus, that's root 3 over 2 times root 3 over 2, right? So that is equal to root 3 pi over 6 plus 3 over 4, right? So finally, our equation of tangent line is, let's make some space right here. Y minus y1 is equal to slope m, x minus x1. That's the equation of the line, right? So y minus y coordinate is right here. That's going to be root 3 pi over not 4, 6 plus 3 over 4 is equal to slope m. Slope is right here. So pi plus 6 root 3 over negative root 3 pi x minus x1 is, the point is pi over 6 plus root 3 over 4. So pi over 6 plus root 3 over 4. That's our equation of the tangent line. It's quite complicated, right? Question 847. Write an integral expression but do not solve for the area of reason on the fourth quadrant. Okay, the area of the reason when the polar curve is given, the area is equal to integral from angle to angle 1/2 r squared d theta. That's our formula, right? And we're looking for the area of the reason on the fourth quadrant, right? Here, if angle is equal to 0, r is equal to 0, right? So the graph starts at this point right here. When angle is pi over 2, r is equal to pi over 2 plus a sine pi over 2, which is equal to 1. So that's going to be pi over 2 plus 1, right? So when angle is pi over 2, r is, this is about 1.5 plus 1, 2.5. It's right over here, right? So at this point right here, the coordinate is 0, pi over 2 plus 1. Does that make sense? So we're looking for the area of the reason on the fourth quadrant, right? So our interval of angle must be from 3 pi over 2 to 2 pi, right? From here, starting from here, right? And all the way to here, right? 2 pi. So we can find the area of this reason right here, right? So our integral expression must be equal to from 3 pi over 2 to 2 pi 1/2 times r squared. R is theta plus sine theta, right? So theta plus sine theta square d theta, right? That's our area of the reason on the fourth quadrant of this polar curve, right? Question 848. The graph above shows the polar curve r is equal to theta squared and r is equal to 4. 4 theta is from 0 to pi. Find the area of the reason A. Okay, the figure is right here, and we have two polar curves. R is equal to 4, that's a circle with the radius 4, right? So this curve is r equal to 4. R is equal to theta squared. That's this curve, right? And we have intersection here. When we have two polar curves and they intersect at some point, always draw a ray from the pole or the origin to this intersection, right? Now we have to find the angle from here to here, right? Okay, at this point right here, the r from this curve, which is this, r from this curve at this angle is this, right? They have the same values of r, right? So we're gonna let this r is equal to this r, which is a theta squared is equal to 4. Then theta is plus or minus 2, but in this case, that must be positive, plus 2, right? Because the theta is from 0 to pi. Okay, so theta is equal to 2. Okay, now our strategy to find the area of the region A is we're going to find the area from here to here from this curve. R is equal to theta squared, right? Sector, 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 all the way to here, right? And then after this angle right here, after theta is equal to, we're going to have to find the area of this region, right? From the curve r is equal to 4, right? So we're going to have two different integrals. And first one is from 0 to angle theta is equal to, the formula is 1/2 r squared, right? R squared d theta. And remember, this r is this r right here, which is theta squared, plus integral from the angle 2 to pi, right? This angle right here from 2 to pi, 1/2 r squared d theta. This time this r is this r, right? R is equal to 4. That's our area of the region, right? So let's solve this. Here we have 1/2 times integral from 0 to 2 r squared theta to the power over 4 d theta, right? Plus 1/2 2 to pi r squared, r is equal to 4, right? So 4 squared d theta. So far so good. Now let's solve these definite integrals. So 1/2 here, antiderivative of theta to the 4 in terms of theta, right? So theta to the 5 over 5 from 0 to 2 plus 1/2, that's a 16, right? So 16 theta from 2 to pi, right? So that's going to be equal to 1 over 10. If we substitute 2 for theta, that's going to be 32. 0 for theta minus 0 plus 8 times, that's going to be pi minus 2, right? So if we simplify this, 32 over 10, that's a 16 over 5 plus 8 pi, and we have a minus 16. So that is equal to 8 pi equal to 8 pi. Negative 16 plus the 16 over 5, that's negative 64 over 5, right? So this is our area of the region A, okay? Question A50. A particle is moving along the polar curve r is equal to theta squared so that its position at time t is x, y, and d theta over dt is 1/2. What is the value of dx over dt at theta is equal to pi over 2? Interpret the meaning of this value with respect to the polar curve r is equal to theta squared. So the question is to find the value of dx over dt when theta is equal to pi over 2, right? And we know that x is equal to r cosine, right? And r is a theta squared, so x can be written as a theta squared times cosine theta. X is in terms of theta, but we're looking for dx over dt, right? So we're going to have to use the chain rule. dx over dt is equal to dx over d theta times d theta over dt. Well, dx over dt can be written as this product of these two derivatives, right? Since d theta cancels out. So dx over d theta, that's a derivative of this equation right here, right? So dx over d theta is equal to, since x is a theta squared times cosine theta, we're going to have to apply the product rule, right? So derivative of theta squared, that's 2 theta, and we have cosine plus theta squared times the derivative of cosine, that's minus sine, right? So we have 2 theta cosine theta plus, well, actually minus theta squared sine theta times d theta over dt. d theta over dt is given. It's 1/2, right? So times 1/2. So far so good. And we are looking for this derivative when theta is equal to pi over 2, right? So we're going to substitute pi over 2 for theta. Okay, pi over 2 for theta right here. So that's going to be equal to 2 times pi over 2. Cosine pi over 2 is 0, right? So 0 minus pi over 2 square times sine pi over 2, which is equal to 1, times 1/2. So that is equal to, all of this thing is 0, right? This expression, that's pi square over 4 times 1/2. So that's going to be negative pi square over 8, right? So our dx over dt when theta is equal to pi over 2 is negative pi square over 8. And we have one more question here, right? It says interpret the meaning of this value with respect to the polar curve r is equal to theta square. So the particle is moving on this polar curve right here, right? R is equal to theta square. And when theta is pi over 2, our particle is right here, right? When theta is equal to pi over 2. And its rate, the rate of x with respect to time t, is decreasing. The rate is negative, right? It means our x value is decreasing at a rate of a pi square over 8 at this point right here, at this angle right here. Does that make sense?